What do you think the word midpoint stands for? The point in the middle, okay? Now, when you start to think about the point in the middle of something, that means that you are exactly halfway between two things. So you might want to write stuff down. Call me crazy. Taking notes and writing examples is good. If you need paper, would you stop for a second and show everybody where there's spare paper on that back, those little freehand? There's paper. So there's stuff there for you guys. Now, last time I checked, the ruler is generally 12 inches. What's the halfway point of 12 inches?
6 inches.
So if you balance it at the 6, it should stay there. Okay? That means, being the midpoint, you have 6 inches on one side and, dun dun dun, 6 inches on the other side. The midpoint is the halfway point of a segment. The midpoint takes a segment and it cuts it into two equal or congruent segments. What we look at here a lot of times is that there's a real basic definition. The midpoint of a segment is the point that divides a segment into two congruent segments. Just like you said, you can put your finger on a ruler at the 6 and balance it. That's the midpoint. Okay? A lot of times I will write midpoint because, you know, it's too many letters. M, D, P, T. Midpoint. I abbreviate. I abbreviate just about everything because we can, and it's easy, and it makes sense, hopefully. Okay? So when we're talking about midpoint, you'll see it written sometimes as M-I-D-P-T or M-D-P-T, just stuff like that. The midpoint, like I said, is a point on the segment that divides the segment into two congruent parts. So as we start to talk more about the language of this, you will start to see stuff written as like the following. Let me just move this out of the way real quick and I'll show you. For example, point X is the midpoint of segment AB. So if you read that point X is the midpoint of segment AB, what does that tell you where X is? In the middle. And your endpoints are A and B. So you can draw a segment then with endpoints of AB and put X in the middle. Now, knowing that X is the midpoint, that means those two segments now are equal in length. So we call them congruent. I don't know what their values are, but I know that they're equal to each other. Remember last week, or actually I think it was even Monday, when we talked about how you mark diagrams for congruencies? How would I mark those two? Remember how we did that? Exactly. Very good. I would just do a little tick mark like this. That shows that AX is equal to XB, or you can imply that then eventually we'll start to say that AX is congruent to XB. Now, not to get too far out ahead of ourselves here, is that eventually we are going to start to talk about the nasty 4-letter word 2-column proofs.
That's a T-chart.
It's a 2-column proof. And it's the same basic idea where you have your statements. It's statements and reasons is what we use these for. Now, what will happen here eventually is that you are going to be given information. For example, if you are given X is midpoint of AB, and that's what we would say a given statement. Well, anytime that you have something given to you, there's probably a definition behind it. Well, according to our definition of a midpoint, that implies that X has cut that segment into two congruent parts. So the next thing I would always say then is that, well, what are the two congruent segments? Well, that has to be AX is congruent to XB. And the reason that they wind up being congruent to one another is because of what we use as the definition of a midpoint. So as we go along, you're going to start to see more of these definitions where we can take them, and we might not be using a ton of it now, except for some algebra stuff, but eventually we're going to turn to use them within logic, within reasoning. How do you write out a set of statements that make sense? So that's not quite there where we're going to be at. We still got a couple months to go for that, but what I want you to start to think that anytime that I give you information, there is a midpoint. Well, what does a midpoint do? It cuts and creates two congruent segments. Next week we're going to talk about an angle bisector. If something is an angle bisector, it cuts an angle into two congruent segments. Two congruent angles. So we're going to start to see things like this. Another one that we talked about a little bit today is what we call a bisector. A segment bisector is more of a general term. It does the exact same thing as a midpoint. But it's just saying that not always do you have just a midpoint. It could be a ray that goes through it, another segment that goes through it. It could be a line bisecting a segment. Anything that you say is a bisector, it sections it into two parts. Hence the word bisector. Section and two. And they just are equal. So a bisector runs through a midpoint. It cuts it into two congruent spots. It's basically the exact same thing. Like I said, really the only difference is that the diagrams might not be a point. It could be a segment. It could be an array. It could be another line. It could be anything. Ooh, can you bisect a line?
Yeah.
How can you cut something in half if it's infinite? Exactly. There is no midpoint of a line. There is no midpoint of that. Is there a midpoint of a ray? No, because it also has an infinite to it. Really, the only things that have midpoints or that can be bisected are things that have endpoints. We can bisect any segment, and we can bisect any angle. I don't want to get too far ahead of myself, but these terms and stuff, guys, they mean the exact same thing when we deal with angles or we deal with segments. Segments are straight across from one another, angles turn. That's it. That's really the only thing that's going to change. Okay? Not too scary? Now, with this then, it's going to allow us to set up and do some very, very easy algebra. So if we go back to the idea that I had x is the midpoint of that segment AB. So we have A, B, and this was x. So x is midpoint of AB. What does AB equal? This came up first hour, and it comes up pretty regularly. Is it the end of the world if we forget to put that little bar over a segment piece? Not really. As long as we're labeling it, we're gonna be okay. I don't want a lot of the perfect ways of writing out and drawing the lettering to be a hindrance. I'd rather you guys be able to use the definition and solve problems, as opposed to worrying about what should this be labeled as. Okay? That's what I'd rather you do. Let's write something down. You're sitting in the front. Come on, look busy. Okay? So, knowing that we have a midpoint, that means we have two equal segments, or two congruent segments. What are the two segments that are created that are equal to each other? And? Okay. So since x is the midpoint of AB, then we can say that AX equals XB. Well, what does AX equal in this diagram? What does AX equal? Let me ask you a question. What does XB stand for? So like I said, and I've been saying this a lot, geometry uses algebra over and over again. It's just algebra within geometric terms. That's it. Algebra doesn't go away, guys. We use it here. We obviously use it in Algebra 2. You go into stats or into a pre-calc, you're going to use algebra over and over again. There's a lot of solving for x in math. That's kind of what we do. So now you have variables on both sides of the equation. What do? Solve. Yes, that's helpful. How about we pick on the little guy?
We can do that too.
Very good. Let's bully these numbers. Take that, 3. How do you move the 3?
Subtract
All right.
it from the 4, add the 1, and
Can I add 1 at the same time, guys? Or do you want me to rewrite it?
add 1 at the same time.
We're saving paper.
We're all kids here.
Well, I wouldn't go that far. Anyway, I get x is equal to 4.
That's what I got.
Now, just like you saw last time, not always in geometry you're just solving for x. You sometimes have to go back to the problem and put it back in. Substitute back in to figure out, well, what are you solving for? In this case, I asked you to solve for AB. So, what's 4 times 4? What's 16 minus 1? So, AX is 15.
So that means XP.
What's 3 times 4?
12,
Plus 3?
15.
Now, you're right, it should be 15. The reason that I wanted to make sure it was 15 is so that way I didn't see that I goofed. Okay? So, what are you setting it equal to, though? Yeah, but do you know what AB? Oh, you're just putting it all together? Yeah, the only thing that I'm saying is that what happens if your number was wrong and you get 15 for one and 12 for the other? See what I'm saying? But I know where you're getting at. Oh, it doesn't take long to check it. That's a good question. So what's your overall length then? Huh? 30. Really, really simple stuff. Okay? Really simple stuff. I hope. I shouldn't be undermining it. Okay. Which allows you then to not only use algebra, but sometimes we might have to use coordinates. Now, I'm not worried about the graph stuff, so don't graph this. But I want to talk about midpoint. Remember, midpoint is just a halfway point. It's the average of two numbers. Okay? You got any money on it? Yeah. How much? $5. Okay. You've got $5. I think I didn't spend any last hour, so I still have 41. So, what I want to do is that he has $5. And I have $41. I know. It's weird. I have cash. I've never carried cash. What is the average amount of money between the two of us? If I want to find an average, what do? Add them and then what?
Divide by 2.
In this case, there's just two of us, so I just divide by 2. If there were 3 of us, we would divide by
3.
and so on. So you guys know how to find averages, right? So what's 41 and 5?
46.
So what's half of 46? You okay there?
$23.
So the average amount of money between the two of us is $23. Now, why I wanted to say it like that is because when you're dealing with midpoints as far as what are called coordinates are concerned, all you're doing is that exact same thing twice. Because when you talk about a coordinate has an x value and a... So if I have 2 points that connect a segment, wouldn't I have 2 x values and 2 y values? So all I have to do then is, in order to find the midpoint formula for ordered pairs, is you just find the average of x and y. And this is what it looks like. when you have a set of ordered pairs, remember how we labeled them before? We'd say it was like x sub 1, y sub 1, x sub 2, y sub 2. I know you guys are going to say, yes, I remember that verb.
Yes, I remember that.
Thank you for paying attention.
Does that say one, find the one, or what does that say?
Average. So here's what happens. This midpoint is always equal to, that's why I used the little m, x, midpoint, y, midpoint, the coordinate value, is always going to be equal to the two x values added together, divided by 2, and the two y values, added together and divided by 2. And that's where this stems from. When you have ordered pairs, you'll have your ordered pairs. First x, first y, second x, second y. That midpoint, that halfway point of those, all you're going to do is add the x's together, cut it in half. Add the y's together, cut it in half. Okay? You might not be able to read this very well, but this ordered pair is at, oh, when you're reading ordered pairs, which ones are the x's, the left and rights or the up and downs?
With the x's?
Yes.
Left and right?
Left and rights, good. So then your up and downs then are your,
Y's.
what comes first in the ordered pair?
X,
And then,
Y.
so in this example here, I have a set of ordered pairs. Let me just do this so I can room.
Oh. Oh.
At -4 and 2, and the other one is at 3 and 6. Does it matter which one I label first as my first set of x's or my first set of y's? It doesn't matter. To be honest with you, a lot of times if I'm looking at a graph, the ordered pairs are there. I just read it from left to right. There's my first x value. There's my second. That's all. So, what's that? Yeah. Yes. Everything in one. That's the plan still. Well, who knows? The reason it doesn't, it matters for which one's the x coordinate, but how you label it, let's say you called your x sub 1, y sub 1, 3, 6, and the other one be x, it won't matter. It works the same because you're just adding. Because 2 plus 3 is the same as 3 plus 2. So if I go back into here then, I'm going to go over to the other side so I had them written down. These are my ordered pairs that I started with. My first x, my first y, second, and second. So I take the first x and the second x, I take the first y's and the second y. What was the first x value in here?
2.
Let's try again. What's the first x value here? -4, second x value.
3.
What's the first y? And then? Now here's where this whole idea of using that multi-view calculator is going to be so important. Because the multi-view calculator has the button that says fraction, n over d. Because when you put this in your calculator,
Can we do it so we can get a satisfaction?
yeah, please do. Because I want to show you what happens if you don't use the fraction bar versus using the fraction bar. If you have the fraction bar button, it's your best friend. Because it allows you to do all the work without much hassle. All I have to do is type it in exactly the way I see it. -4 plus 3 over 2. And I hit enter. And I get -1/2. There's my answer. My midpoint for the x value is at -1/2. I do it again, make a fraction bar. Mine's a little bit different than yours, but it still does the same thing. There's, you press it first. And then, there you go. Yeah, for those calculators, you hit the fraction bar first and then put it in there.
You get more.
And then you get 2 plus 6 over 2, and you get 4.
Wow.
So the average of my y values is at 4.
It's kind of raw.
That means my midpoint is at -1/2 and 4. Now here's the deal. If you don't use that fraction bar, watch what happens. -4 plus 3 over 2. -2.5. That ain't right, is it? What is it doing?
Is dividing the 3 and the 2.
Yep. It does order of operations as you would the PEMDAS stuff. Calculator thinks PEMDAS. It does
So-
not split it apart.
So what if you do -4 plus 3, then hit enter, then divided by 2?
That works.
Okay.
That works.
I didn't.
Same idea with this 2 plus 6 divided by 2, and I'm getting 5, which is not the right answer. You need to use the fraction bar. The fraction bar is your best friend, okay? All right? If you don't have a fraction bar, I'm telling you guys, it's the best 15 bucks you're ever gonna spend. It really is. Otherwise, you're gonna have to get used to using parentheses and then rewriting your decimals as fractions, because fractions are what we're gonna use. All right, we can't walk decimal slopes. We can't, it's very difficult to do most math, upper level math problems when you start dealing with decimals. Fractions are what makes everything so much easier to work with, okay? Try another one real quick. You got a couple minutes, right? You got a couple.
Wait, so, like, all this ways on Friday, I was thinking of, like, question, are you gonna,
It would say find the midpoint.
and then it's against points?
Yeah.
That's it?
We can make it more difficult if you like.
No.
Let's see, this one is, take a second and do this one. I'll just write the ordered pairs for you. -3, -4, and what was that, 6, -6. Get me the midpoint of that rather quickly, please. It doesn't. Got a little screen all messed up. Oh, it's still like so. Press it with a pen or something, or the LCD. Don't do that. Don't do that. Yes, sir.
Oh, I shut you.
Whatever. Okay.
Okay.
Is it okay if we get a fraction?
I want fractions. If it's a fraction, I want fraction, yes.
Oh, okay.
Because fractions happen, they're a lot easier to work with than non-fractions.
You're supposed to get that.
So, did I say let's use a fraction? Fractions. I don't want any decimals.
Decimals are easier to work with.
Okay, how about this? Go ahead and multiply 0.25 times 0.5. The answer is 1/8. Because fractions are easier. Was that the mic drop? The bell's gonna ring in a minute. You can wait. All right. With no case.
No!
That's good.
That's how you hide your case.
So again, as we get into this stuff, take a second and write it out. Take a second and write it out, guys. Watch your signs because that's where you're gonna mess up. In the calculator, as you're typing them in, make sure you're using the negative symbol, not the minus button. The negative button is next to the decimal. -3 plus 6. All over 2. You get 3 halves. Okay? -4 and -6 is how much?
Negative 5.
And half of negative 10 is
Wait, what?
negative 5.
Oh, yeah. I just.
If the average, how many things are you adding together? So you divide by how many?
No.
So what happens then if you were to look at this graphically, 3 halves is 1.5. That means these two segments there would be the same. Yes, sir?
Wait, why'd you say negative 10 and then negative 5? Because when I just put it in the calculator, it's giving negative 5.
I didn't have a calculator, so I did negative 4 plus negative 6 equals negative 10. Half of negative 10 is? There you go. What I want you to do tonight, I believe this is page 19 in the book. Let me double check that. Yep. I'd like you to go and do numbers 8 through 22 evens, please. Okay? It's a couple of algebra problems, couple of midpoint problems, nothing crazy. It talks about bisector on number 10. It says point T bisects segment UV. There's no diagram, so what should you do? Draw it, make the diagram. That way you can label out what parts you're working with. Use the calculators for fractions, guys. They're gonna be your best friend, okay?
Yes.